Hello students, this is Latif sir. Today I'll discuss about ISC class 11 chemistry, the second chapter, structure of the atom. Today I'll discuss about electromagnetic radiation. So what is an electromagnetic radiation? The radiation which are associated with electrical and magnetic field. The radiations which are associated with electrical and magnetic field are called electromagnetic radiations. That is, an electromagnetic radiations consists of two components. One is electric field, another is magnetic field. Now when an electrically charged particle moves under acceleration, alternating electric field and magnetic fields are produced and they transmitted. These fields are transmitted in the form of waves, and these waves are called electromagnetic waves or electromagnetic radiations. Okay. Now properties of electromagnetic radiation. Oscillating electric and magnetic field are produced by oscillating charged particle, and these fields are perpendicular to each other and both are perpendicular to the direction of propagation of wave. So an electric field consists of two component. One is electric field, another is magnetic field, and they are always perpendicular to each other, and they are perpendicular to the propagation direction of the propagation of the wave. And how an electromagnetic radiation or electromagnetic waves propagates, this look like this. In this figure you can see that electric field and magnetic field, huh, both are perpendicular to each other. Okay, and they are perpendicular to the direction propagation of the wave. And second properties of electromagnetic wave radiation, that they do not need a medium to travel. That means they can even travel in vacuum. They do not need a medium to travel. That means they can even travel in vacuum. Now characteristic of electromagnetic radiation. So let's see the characteristic of electromagnetic radiation. First, wavelength. It is denoted by lambda. What is wavelength? It may be defined as the distance between the two neighboring crests or towers of a wave. You have already studied in class 10 physics about the uh, transverse wave of light. Light propagates in the form of transverse wave. Okay, and there are many trough and crest. I think you can remember this one. And the wavelength is the distance between the two neighboring crest or tau, and it is denoted by lambda. Now second characteristic is frequency. It is denoted by nu. It looks like v, but it is nu. Okay, frequency is denoted by nu, and frequency is defined as the number of waves which pass through a particular point in 1 second. Frequency, it may be defined as the number of waves which pass through a particular point in 1 second. And next characteristic of electromagnetic radiations is velocity. It is defined, it is represented by c, and it is defined, velocity is defined as the distance traveled by a wave in 1 second. Velocity is defined as the distance traveled by a wave in 1 second. In vacuum, all type of electromagnetic radiations travel with the same velocity, and its value is 3 into 10 to the 8 meter per second. Okay, so any type of electromagnetic radiations, that is any type of light, gamma ray, x-ray, ultraviolet rays, visible, infrared, microwaves, any types of electromagnetic radiations which consist of two component, electric field and magnetic field, and they are always perpendicular to each other, and they perpendicular to the direction of propagation of the wave. Okay, and all types of electromagnetic radiations propagates in a velocity c. The velocity is 3 into 10 to the 8 meter per second in vacuum. That is, velocity of all type of electromagnetic radiations are same, and the velocity is 3 into 10 to the 8 meter per second in vacuum. But the value of wavelength and frequency are different for different types of electromagnetic radiations. Okay, you have to remember the value of wavelength and frequency are different for different electromagnetic radiations. Okay, but the value of velocity of defined electromagnetic wave radiations are same in vacuum. And scientist Maxwell told that any types of electromagnetic radiations huh, travels in the form of waves, and if a body emit or absorb energy, they absorb or emit energy continuously, not discontinuously. Who told? Scientists Maxwell told that any type of light propagates in the form of radius waves. Okay, and that is their radiations. There any types of any types of radiation propagates in the form of wave. Okay, any type of light, radiations or lights are same. You have to remember this one. Radiation means light, light means radiation. There are many types of electromagnetic radiations: UV radiation, gamma radiation, IR radiation, visible radiation or visible light. You can also say UV. Uh, you can also say this radiation as waves. Okay, and according to Maxwell, if a body emit or absorb energy, they emit or absorb energy continuously, not discontinuously. Later scientist Planck uh, state uh, state something, but according to Planck, if a body emit or absorb energy, they emit or absorb energy discontinuously, not continuously, just opposite of Maxwell. Now let's see this next characteristic of electromagnetic radiation is wave number. What is wave number? Wave number, it is denoted by nu bar, the symbol nu bar. Frequency is denoted by nu, while wave number is denoted by nu bar. And nu bar is the wave number. Wave number is defined as the number of wavelength per unit length. Per unit length of the wave. Wave number is defined as the number of wavelength per unit length of the wave. And the relation between the velocity, frequency, and wavelength of the electromagnetic radiation is velocity is equal to frequency into wavelength. That is, C is equal to nu into lambda. C is equal to nu lambda. And this figure shows that different types of electromagnetic radiations, they are arranged in according to their frequency and wavelength. Uh, from left to right you can see here it is written gamma rays, x-ray, UV, then light means visible light, next infrared, and last radio waves. And from left to right wavelength increases but frequency decreases. Huh. So from left to right, wavelength increases, frequency decreases, and energy also decreases from left to right. That is, from right to left, energy increases. From left to right, energy decreases. Okay. And gamma rays, the frequency of gamma rays is maximum, and frequency of radio is minimum. While wavelength of gamma rays is minimum, and wavelength of radio wave is maximum. Now Planck quantum theory. This is just opposite of Maxwell theory. So according to Planck, the radiant energy is emitted or absorbed not continuously but discontinuously. While Maxwell told that the radiant energy is emitted or absorbed is continuous. That is, they emit or absorb energy continuously. But scientist Planck told that radiant energy is emitted or absorbed not continuously but discontinuously in the form of small discrete packets of energy called quantum. And in case of light, the quantum of energy is called a photon. So Planck assumed that light particles, any type of light, consist of a small packet of energy. Huh. While Maxwell assumed that light is a wave. Huh. Light is a radiation. While Planck assume that light is consist of small packet of energy which is called photon, and the energy of proton or energy of each quantum is directly proportional to the frequency of the radiation. That is, E means energy of photon or energy of each quantum is directly proportional to its frequency nu. So E proportional to nu, or E is equal to h nu, where h is a constant. H is a constant called Planck constant. H is Planck constant, and value of Planck constant is 6.626 into 10 to the power minus 34 joule second. And next point of Planck quantum theory is energy is always emitted or absorbed as integral multiple of this quantum. That is, energy is always integral emitted or absorbed is integral multiple of h nu. That is h nu, 2h nu, 3h nu, 4h nu, like this. So you can also write E equal to nh nu, where n is 1 2 3 4 5 6. So energy is always emitted or absorbed as integral multiple of this quantum or photon. Okay, in case of light it is called photon. Now black body. What is black body? An ideal body which emits or absorbs all frequencies is called a black body. A ideal body which emits or absorbs all frequencies is called a black body, and the radiation emitted by such a body is called black body radiations. Next, photoelectric effect. What is photoelectric effect? The phenomenon of ejection of electron from the surface of a metal. The phenomenon of ejection of electrons from the surface of a metal when light of suitable frequencies strikes strikes it strike it is called photoelectric effect. That is, if you fall some light of suitable frequency on a metal surface, electron will eject from the metal surface. This is photoelectric effect. The phenomenon of ejection of electron from the metal surface, when light of suitable frequency strikes it, is called photoelectric effect, and the ejected electrons are called photoelectrons. So you have to pulse light of suitable frequency on different metals to get photoelectrons. Okay. Now experimental results observed for the experiment of photoelectric effect. Photoelectric effect. Experimental results observed for the experiment of photoelectric effect. When a beam of light falls on a metal surface, electrons are ejected immediately. And the number of electrons ejected is directly proportional to the intensity or brightness of the light. You have to remember, the number of electrons ejected is proportional to the intensity or brightness of the light. Next point, threshold frequency. I have told that you have to fall light on a metal surface to get photoelectron, but you have to fall a light of suitable frequency. For different metal, the frequency, this suitable value of this suitable frequency are different. Okay, so what is the threshold frequency? For each metal, there is a characteristic minimum frequency. For each metal, there is a characteristic minimum frequency below which photoelectric effect is not observed. That is, photoelectrons will not eject from the metal surface. If you fall the light of some minimum light below some minimum frequency. So for each metal there is a characteristic minimum frequency below which photoelectric effect is not observed. This is called threshold frequency. That is minimum frequency of light. Uh, this threshold frequency is the minimum frequency of light to get the photoelectric effect. Below, if you fall light of frequency below the threshold frequency, you will not get the photoelectric effect. That is, the electrons will not eject from the metal surface. Okay, so threshold frequency, it is represented by nu zero. It is represented by nu zero. For each metal, there is a characteristic minimum frequency below which photoelectric effect is not observed, and this is called threshold frequency. And you have to remember that for different metals, the value of threshold frequency is different. Okay. If frequency of light is less than the threshold frequency, there is no ejection of electrons, no matter how long it falls on the surface or how high is its intensity. So threshold frequency is the must for ejection of electron. If frequency of light is less than the uh, less than the threshold frequency, there is no ejection of electron from the metal surface, no matter how long it falls on the surface or how high is its intensity. Now work function. What is work function? Work function, it is represented by W0 or omega 0. Okay. The minimum energy required to eject electrons from the metal surface is called photoelectric work function. So what is work function? The minimum energy. It is actually energy. Huh. The minimum energy required to eject electrons is called photoelectric work function, and the minimum frequency required to eject electron is called threshold frequency, and the minimum energy is called to eject electrons from the metal surface is called photoelectric work function, and W0 or work function is equal to h nu 0. I have told according to Planck, energy is equal to h nu. So uh, here the work function energy, it is also energy, so you can also write W0 is equal to h nu 0. Here the frequency is nu 0. Okay, that's why W0 is equal to h nu 0. This is the work function to eject electrons. Minimum, this is the minimum energy to eject electrons. Now Einstein explanation for photoelectric effect. Einstein proposed that when electromagnetic radiation of frequency nu falls on a metal and a photon hits an electron, the photon disappears, transferring its energy to the electron. I have told that light, according to Planck, light consists of a small packet of energies which are called photons. And when you fall light of frequency nu, photon light means photon. There are many packet of photon energy which are called photon. And when you fall light on a metal surface of on a metal surface, the photon of the light will hit an electron from the metal surface huh, on the metal surface, and the photon disappears and photon transfer his energy to the electron present in the metal surface. That's why electron uses part of this energy in overcoming the forces that hold it in the metal and the rest of energy escapes, and the rest of energy appears as the kinetic energy of the emitted electron. So when you fall a light of frequency nu on a metal surface, first the electron from the metal surface will eject. Then huh, for ejection of electron, some minimum energy is required, which is called work function, that is h nu 0. So you have uh, uh, fall a light of frequency nu, so energy is h nu. Huh. So total energy fall on the metal surface is h nu. Huh. From this energy h nu, some part, that is nu W0, that is work function. huh, W0 is needed to eject electron from the metal surface, and the remaining part of the total energy h nu huh, increases the kinetic energy of the electron, that is half mv square. So according to Einstein, you can write h nu 0, total energy fall on the metal surface, is equal to work function, that is energy required, minimum energy required to eject the electron, plus half mv square. Half mv square is the kinetic energy of the electron. So total energy is used to eject the electron and to increase the kinetic energy of the electron, that is h nu you can write according to Einstein, h nu is equal to w0 or omega 0, which is work function, plus half mv square, or h nu is equal to, you can write the value of w0, that is h nu 0, and after arranging the equation look like h is h into nu minus nu 0 is equal to half mv square. This is Einstein equation of photoelectric effect. Now, dual behavior of electromagnetic radiations. According to Maxwell, electromagnetic radiations propagates in form of wave, while according to Planck, electromagnetic radiations consist of small packets of energy called photons or quantum. I have told that. So light, you can also think that light light have two nature, dual nature. One is particle nature, another is wave nature. So according to Planck, light possesses particle nature, and according to Maxwell, light possesses wave nature. Radiation possesses wave nature. So dual behavior of electromagnetic radiations. The light possesses both particle and wave like properties. That is, light has dual behavior. Whenever radiations interact with matter, it displays particle-like property. For example, in case of black body radiations, photoelectric effect, light is assumed as particle, while the wave-like properties are exhibited when it propagates. That is in case of interference and diffraction. Uh, it is assumed that light propagates in the form of wave. So in some cases you have to think that light act as wave, while in some cases you have to think that light act as particle. Light consists of particles, so light has uh, both nature, particle nature and wave nature. Okay, to explain different phenomenon you have to assume in some cases particle nature of light, in some cases of wave nature of light. Okay, for example, in case of black body radiation photoelectric effect, you have to think that light is a consist of particles, and in case of, to explain the phenomenon of interference diffraction, you have to think that light act as wave. Okay, that is light propagates in the form of waves. Okay, thank you.